Good afternoon, everybody. So today we're going to be talking about addiction, and we're going to be addressing the objectives on screen right now. So I want you to think about your favourite things to do and why do you do them. Things that come to my mind is play guitar, play rugby, eating my favourite meal, which is a Gloucester grill, of course. If you know, you know. Half chicken, chips, nice peri mayo there from Boss. Keeping us been coming back since 2014 now. And there's a reason I like these things. It's because I enjoy them. That might have been different for you, but generally we do things what we enjoy, and this is by design. So all humans do things for a feeling of reward and are motivated by an extent of anything that we do to feel that reward as it reinforces that behaviour. Many natural rewards, one of which I mentioned, food, include sex, food, social connection and exercise. Some drugs and other activities also act on the same reward system, which we'll be talking about, of these natural rewards, and can cause problems when it comes to addiction. Definition of addiction is when you have a strong need to do something. It can be physical or psychological, or often a combination of both. It is a dependence on a substance or activity, which even if you know it causes you harm, it can impact your daily life. One of the things I want to talk about while we're on that note is actually some addictions might be considered healthy, such as exercise. However, too much of anything can be a bad thing, and in some people with eating disorders, they can have an overwhelming desire to exercise more than what they eat, and that can itself be an addiction which is maladaptive. Within the brain, there are about 3 pathways that are associated with the neurotransmitter dopamine, which we're talking a lot about today. I've highlighted in red the mesolimbic system, which is the one that we will focus on. And this is linked to the VTA, or ventral tegmental area, and the nucleus accumbens, which is the main reward centre within the brain. However, it's also noteworthy that in the mesocortical system, the ventral tegmental area is connected to the prefrontal cortex, which is involved with thinking. So sometimes some of the cognitive effects of addiction can affect the mesocortical system as well. So dopamine transmission, like any other neurotransmitter, works when dopamine is released from a neuron, or the presynaptic terminal, and it passes across the synapse and it binds to a receptor, in this case dopamine receptors, of which there are many types. As a result of the dopamine binding to postsynaptic receptors, action potentials, or nervous impulses, can be increased, and over long periods of time the neurons will change shape and rewire, altering their function, and this can lead to some of the brain changes that we see within addiction. Now, this pathway was found around 70 years ago through experiments within rats, like many other things within neuroscience. Scientists Olds and Milner experimented with electrodes being placed within the brains of the rats, and they placed a lever within the cage of the rat, and the rat would stimulate itself essentially by allowing the electricity to shock a certain area of the brain. And they noticed that when the electrodes were situated at the nucleus accumbens, the frontal cortex, and the ventral tegmental area, or as we now know them, the mesolimbic reward system, the rats would choose themselves to stimulate themselves a lot, choosing this stimulation over all other needs, including sex, food, and care for themselves. And it was shown that the dopamine was the key neurotransmitter involved within this, as if dopamine was inhibited, then this behaviour of self-stimulation would stop, thus stopping their addiction to shocking themselves. Many of the drugs of abuse that we know act within the dopamine or the mesolimbic pathway, and as we can see from the graphs, lead to rapidly increasing levels within dopamine. This is followed by a steady decline, and sometimes decreasing that dopamine to below baseline levels. The resulting effects from these drugs of abuse being used on a repetitive way lead to lowering of the levels of the dopamine within the system that is available, as well as sensitivity to that dopamine, which we'll talk about in a minute. Different drugs bind to different receptors and thus act in different ways. Opiates and alcohol bind to GABA, which is an inhibitory neurotransmitter, which normally keeps the dopamine at balance. When GABA is inhibited itself, this leads to excessive dopamine. Nicotine, one of the quickest acting addictive drugs, binds directly to the nicotinic acid receptor, or NACHR, and this leads to direct dopamine release very, very quickly. And then stimulants such as cocaine and amphetamines actually inhibit the reuptake of dopamine from the synapse, leading to a flood of dopamine in the synapse and its continued effect being released. Dopamine levels become abnormally low following persistent use of addiction, and this can actually lead to reductions in the ability to experience pleasure as a result of other stimuli. This is known as anhedonia and is associated with depression. In fact, it's one of the key symptoms within depression. And indeed, many individuals with addiction to various substances and activities do report anhedonic symptoms. Individuals will actually tend to take more and more and more of this dopamine to feel normal, when in reality it is a vicious cycle which leads to perpetual seeking with reduced reward. We can actually see here some brain scans showing how habitualization and tolerance of the repeated behavior affect the dopamine system. These are PET scans which look for the dopamine receptors D2 and D3, and these find that over time those dopamine receptors are being reduced within drug users. It's also interesting to note that people with obesity who might have eaten a lot of processed sugary foods also have reduced dopamine receptors. Why might this be? The reason being is because sugar in itself is very rarely found within nature. Sugar and fats together, very rarely found. But obviously in the processed diets which many people within particularly Western societies are now exposed to, it is abundant. And it leads to dopamine spikes, not as high as those drugs that we've just seen, but not far off. And therefore, over time, leads to sensitization of the dopamine system and leads to reduced dopamine receptors, as we can see here in the MRI scans, the PET scans. And here we can see it on a graph that there's a significant difference in the dopamine receptors of obese subjects, significantly lower than control subjects. And this is from a 2001 study by Wang and colleagues. Now, modern drugs that are recent, or I'll call them modern drugs for now, include things like social media, Instagram Reels, TikTok, YouTube Shorts, all of which are novelty seeking. They themselves may well have similar effects on the brain. They certainly have effects on the brain, and we'll cover that in another episode. But they are incredibly addictive as well, and might also result in anhedonic symptoms, as well as impacting the sleep of an individual, which we know can cause a wide range of effects. Aside from biological standpoint, there are many other components, such as social risk factors, growing up in deprivation, separated parents, peer abuse, as well as other psychiatric disorders, often leading to an increased risk of addiction as a potential maladaptive coping mechanism. There are, of course, biological risk factors such as genes and family history and variations within the dopamine receptors. However, we cannot look at addiction as a purely biological phenomenon, merely another biopsychosocial illness. Now, when it comes to treating addiction, several options exist and there's mixed efficacy. And it's very important to realise that treating addiction is a complex problem and no one size fits all. I'll just run through some of the different options that we have. So, medically speaking, buprenorphine is a synthetic opiate substitute which we use to treat heroin addicts. And as we can see from the graph, it reduces the use of heroin quite dramatically. However, one might argue that substituting one drug for another drug, albeit less harmful, is not actually getting to the root of the problem at all. Cognitive behavioural approaches are often used in adjunct to pharmacotherapies, including methods such as Alan Carr's Easy Way to Stop Smoking and cognitive behavioural therapy, which can be used to change behaviours, feelings and thoughts surrounding addictions. Community approaches have also seen wide success, including Alcoholics Anonymous and Narcotics Anonymous, which provides social support, which has been shown to increase the chances of someone quitting their substance that they are addicted to, and guidance in a non-judgmental area, which is incredibly important to help people through this time. Social connection and enriched environments are also found to be both protective and helpful in treating people with addiction. This is quite a famous experiment called Rat Park, where they got these rats and they got them addicted to drugs. And they then put some of the rats in a park with lots of things to do, lots of puzzles, lots of food, and various other things for them to enjoy, and then compare them to rats in a standard cage. Now, those rats in Rat Park were now able to resist their cravings because they had other things that would make them happy and enrich their lives. So this is something that also applies to humans, as we saw earlier. Those who are in deprived areas or deprived upbringings are more likely to turn to addiction. This might show some of the linkage there. Here's a few questions you may wish to reflect on in your own time. Thank you very much for watching.